So for lesson 5, we are going to be using some of that right triangle trigonometry that we talked about in the last lesson. So first thing we're going to do is find some missing side lengths. So we have 32 degrees in this triangle on number 1, and we are going to use it as our reference angle. That means that we're going to classify all of our sides in reference to it. So 11 is my opposite side because that's the side that does not touch 32 degrees. X is opposite of the right angle, so it is the hypotenuse. And then my blank side is the adjacent. I always label all three because sometimes it does help students to go, okay, which side is blank and which functions can I rule out because that side is blank. You can also look at it as, okay, I have something on opposite and hypotenuse. What trig function uses opposite and hypotenuse? Well, your answer there should be sine. So we can have the sine of 32 degrees, and that is going to equal 11 over x, because that is opposite over hypotenuse. And then we need to solve for x to find that missing side length. So I will go ahead and treat the sine of 32 as a fraction of being over 1, and then we will cross multiply. So we'll have x times the sine of 32 equals 11 because we did cross multiply. And then to get x alone, we will then divide by the sine of 32. So we'll have x equals 11 over the sine of 32. And at that point, we can put it in your calculator. Do make sure your calculator is in degrees. And so x will equal 20.8. So let's go ahead and look at number 2. 75 degrees is that reference angle. X is my opposite side. My hypotenuse is the blank side. And then 21 is my adjacent. Since I do have something on the opposite and the adjacent side, that means that I need to use tangent. So we'll say the tangent of 75 degrees equals x over 21. And then we will cross multiply. So we'll have x equals 21 times the tangent of 75. And this will go in the calculator. And it will give us 78.4. And on number 3, we have 64 degrees as our reference angle. This time our opposite side is the blank side. Our hypotenuse is x, and then our adjacent is 3. So we are looking for cosine since we have something on our adjacent and our hypotenuse. So we'll have the cosine of 64 equals 3 over x. So we will cross multiply and have x times the cosine of 64 equals 3. We'll divide by the cosine of 64. So x will equal 3 over the cosine of 64. And this is what goes in our calculator. And so x will equal 6.8. So now let's look at finding angle measures. So for angle measures, we will use our arc functions, which are our inverse trig functions. So if the sine of theta equals x, then theta will equal the arc sine of x. So we have a superscript of -1 that shows us that it is the inverse. Same thing for cosine. If cosine theta equals x, then theta equals the arc cosine of x. And if tangent theta equals x, then theta equals the arc tangent of x. So what this means is that the inverse function can undo the trig function. So we will use this to find angle measures because it essentially lets us turn that trig function around. So we are looking for theta, so it's definitely our reference angle. And we're going to go ahead and identify our sides again. So 39 is opposite, our hypotenuse is blank, and then 20 is our adjacent. So if we look, we have something on the opposite and the adjacent. That means that we need tangent. So the tangent of theta is going to equal 39 as the opposite over 20. Well, we need to undo that function with arctangent. So theta will equal the arctangent of 39 over 20. And then this is what you will put in your calculator. And you will get that theta equals 62.9 degrees. So then on number 5, theta is our reference angle again. So we're going to classify it in reference to it. 29 is the opposite side. 52 is my hypotenuse, and then my adjacent side is blank. This means that I need sine. So the sine of theta is going to equal 29 over 52. Of course, we need to undo sine with arcsine. And so that leaves us with theta equals the arcsine of 29 over 52. This will need to go into the calculator. And we will get that theta is 33.9 degrees. And for number 6, we have theta as our reference angle. So that opposite side is blank, but we're given 12 on the adjacent and 19 on the hypotenuse. This means that we need to use cosine. So the cosine of theta equals 12 over 19. So we'll undo that with arc cosine. So we'll have the arc cosine of 12 over 19. And we will put that in the calculator. That will give us 50.8 degrees. And there we go. Okay, so now we're going to put it together and we are going to solve some right triangles. So in number 7, we are missing angle R and then RT and ST. RT and ST are both sides. So the easiest way to find angle R would be to subtract the acute angle we know from 90. So angle R is going to be 90 minus the 34 that we have in angle S. So that gives us 56 degrees. So now we know all 3 angles. So let's look for those missing sides. So for RT, RT is opposite of 34 degrees. And then 42 is the hypotenuse. So in this case, we could go ahead and use sine. So we could say the sine of 34 equals RT over 42. And then we can cross multiply to get RT alone. So RT equals 42 times the sine of 34. So at this point, we could put it into the calculator, and we would get that RT equals 23.5. So now we just need to find ST. So ST is the adjacent side to 34 degrees. So we could go ahead and use cosine. So we could say the cosine of 34 equals ST over 42. And so ST would equal 42 times the cosine of 34. Put 42 times the cosine of 34 in the calculator, and you should get 34.8. Now, this is not the only way to do this problem. This is only one way. There are a lot of open doors on solving right triangles, but one thing that I do suggest is to only use the values that you are given, because if you make a mistake, then everything that you used that faulty measurement to find is also going to be wrong. So let's go ahead and solve number 8. So number 8, we have two sides. We're missing the hypotenuse though. So I would go ahead and use Pythagorean theorem. So that hypotenuse is df. So we'll have df squared equals 21 squared plus 22.5 squared. So 21 squared is 441. 22.5 squared is 506.25. Add those together. You have 947.25. And then take the square root. You have approximately 30.8. So then we do have two missing angles with angle D and angle F, but those can be found using inverse trig functions. So for angle D, I see that I'm given 22.5 and it is the opposite side. Then 21 is the adjacent. So we could go ahead and use tangent. So the tangent of angle D is equal to 22.5 over 21. If we use arctangent, we could say that angle D equals the arctangent of 22.5 over 21. And then put it in your calculator. And your angle should round to 47 degrees. Then for angle F, we can change things around. 21 can be your opposite. 22.5 can be that adjacent. So again, we'll need tangent. So we'll need the tangent of angle F will equal 21 over 22.5. And of course, arctangent again. So angle F will equal the arctangent of 21 over 22.5. This can go in your calculator, and it will round to 43 degrees. Now let's go ahead and look at some word problems. So word problems with trig functions most often employ the use of angle of elevation and the angle of depression. So angle of elevation is usually pretty straightforward. It's the angle created between that horizontal line. Sometimes it's eye line, sometimes it is the ground, but it will be that angle formed pretty much with eye line and something that's horizontal. Angle of depression is a little bit stickier because the actual triangle that you're trying to use is not involved in the angle at all. So your angle of depression is that angle looking down, but usually your triangle is formed on the other side of that. The good news is that usually eye line and the horizontal line in the triangle are usually parallel to each other. This means that your angle of depression should be congruent to the other opposite angle, because since these lines are parallel, then that makes your angle of depression and the angle inside the triangle alternate interior angles, and alternate interior angles are congruent. So whenever you're working word problems, if you have trouble figuring out what's going on, my best suggestion for you is to go ahead and draw a picture. So on number 9, we have a man that is standing at the base of a tower. So we have a man. He is standing 85 meters from the base of a tower. Here is our tower. The tower is 200 meters tall. We need to find the angle of elevation from the ground where the man is standing to the top of the tower. So we are looking for this angle right here. That means that we're going to have to use an inverse trig function. So let's classify our sides. 200 should be the opposite. 85 should be the adjacent. That means that we need tangent. So the tangent of theta is equal to 200 over 85. I would not worry about simplifying the fraction because it's not going to matter. We're about to put it in the calculator. So theta would equal the arctangent of 200 over 85. So this would make theta 67 degrees. So for number 10, we have Sarah, and she is standing 35 feet from the base of a rock wall watching her two sons. So we will draw Sarah, and she is standing at the base of a wall 35 feet away from it, and she has two sons that she's watching. So Max and John. So the elevation is 38 degrees to Max. So this whole bit is 38 degrees for Max, and then to John, it's only 27 degrees. So we need to figure out how many feet above John is Max. So we're going to need to find how high each of them are and then subtract from each other. So for John, his height is the opposite side from 27, and then 35 is the adjacent side. So we're going to use tangent. So we'll have the tangent of 27 equals, we'll go ahead and just say John over 35. And then we'll cross multiply. So we'll have John equals 35 times the tangent of 27. go ahead and put that in the calculator. And you should get that John is 17.8 feet high. Now for Max, we have pretty close to the same problem, but he is at an angle of 38 degrees. So we'll have the tangent of 38 equals Max over 35. So cross multiply, and Max will equal 35 times the tangent of 38. Put that in the calculator. You'll see that Max is 27.3 feet high. So the only thing that's left to do now is to go ahead and subtract Max minus John. So Max is 27.3 feet high. John is 17.8. So the difference between their two heights is 9.5 feet. So next we have a building. So building A is 464 feet tall. And building B is 321 feet tall. And Dale is standing between the two buildings. So the angle of elevation from the point on the ground where Dale is standing is 75 degrees to the top of building A and 48 degrees to the top of building B. So how far apart are the buildings? So we are going to need to find that horizontal distance between Dale and building A and between Dale and building B. So if we look at what we need, we have from 75, 464 is the opposite, and then that horizontal distance is our adjacent. So we're going to need tangent. We have the same situation on the other side with building B. So we're going to need the tangent of 75 degrees equals 464 over A. We'll need a cross multiply. So we'll have A times the tangent of 75 equals 464. So A will be divided. Put this in your calculator. You should get 124.3 feet. And then the tangent of 48 equals 321 over B. So cross multiply again. We'll have B times the tangent of 48 equals 321. So B will equal 321 divided by the tangent of 48. Put that in the calculator, and you should get 289 feet. So if we add these together, 124.3 plus 289, that gives you 413.3 feet. And for number 12, we have something interesting because we will have to convert from DMS form to decimal degrees. And then we also, let's go ahead and read the problem and get our picture drawn. So we have the angle of depression from a helicopter to a landing pad is 34 degrees, 54 minutes, and 8 seconds. So we have a helicopter. I'm terrible at drawing things. So we're going to call that the helicopter. and this is the landing pad. So it says the horizontal distance from the helicopter to the landing pad is 1,200 feet. And we need to find the altitude of the helicopter. So we need to know how far up in the air it is. So the first thing we need to do is we need to go ahead and convert that degree measure to decimal. So if we have our 54 minutes, then we have 54 divided by 60. That's going to give us 0.9. And then our 8 seconds over 3,600, that's going to be 0.0022. We're just going to round it there. So we'll have 34 plus 0.9 plus 0.0022, which gives us 34.9022. So this is how many degrees we have. So now if we look at that angle as our reference angle, then we have x as the opposite. Remember, we're dealing with angle of depression, so this is also 34.9022 right here. But this x is our opposite side. 1,200 is our adjacent. We're going to need tangent again. So we're going to have the tangent of 34.9022 equals x over 1,200. Cross multiply and x will equal 1,200 times the tangent of 34.9022. Put that in the calculator. And you get 837.2 feet. Our last problem for today. We have a scuba diver that spots a shipwreck at an angle of depression of 26 degrees. So here is our diver. He's swimming. And he spots that shipwreck at an angle of depression of 26 degrees. And so here's the shipwreck. And the angle of elevation from the scuba diver up to his boat is 53 degrees. So if the shipwreck is located directly below his boat, so these two are on a straight line to each other, and the horizontal distance between the scuba diver and the shipwreck is 120 feet, then find the vertical distance between the shipwreck and the boat. So we have the distance between diver and the boat, which is x, and the distance between the diver and the wreck, that is y. So we'll need to find each of those and add them together. So for our triangle between the diver and the wreck, our 120 is the adjacent side, and then our y is the opposite. So we will need to use tangent. So we'll have the tangent of 26 equals y over 120. Y will equal 120 times the tangent of 26. So y will equal 58.5 feet. Then we'll have our x. It's also the opposite side from our 53. So we'll have the tangent of 53 equals x over 120. So x equals 120 times the tangent of 53 and put that in the calculator. You should get 159.2. And then you need to add these together. So that's going to be 58.5 plus 159.2. And those will total 217.7 feet. So the distance from the boat all the way down to the wreck is 217.7 feet.